Welcome back to Deep Dive. This is part 2 of our exploration into next-generation AI applications that use agents to connect legacy systems, data, and tools into something much smarter, and dare I say, more human-like in how they handle questions. Last time, we talked about the big picture, how we're moving from old-school button-clicking apps to AI-driven apps that talk, reason, and orchestrate tasks on their own. Today, we're zooming in on the specific Azure services and components that make all this happen, and we'll use a real-world business scenario to tie it all together. Thanks again for joining us.
My pleasure. I'm looking forward to really digging into each piece of the puzzle. When we look at this kind of architecture diagram, it might feel like there are a lot of building blocks. But once we break them down, Azure OpenAI, cognitive search, functions, Cosmos DB, Power Platform, and so on, it starts to feel more approachable. Each service is designed to do one job really well, and together they form a powerful ecosystem.
Let's pretend we're working with a medium-sized manufacturing company. They produce home appliances, things like refrigerators, air conditioners, and ovens. Currently, their data is scattered across multiple systems: an old inventory database, a sales reporting tool built a decade ago, and a set of PDF manuals and policy documents stored on a file share. The goal: give employees a single interface, a chat-based AI agent, to ask questions like, hey, what's the current stock of our latest refrigerator model? Or summarize the warranty policies for commercial buyers and get immediate contextual answers.
Perfect scenario. Let's walk through each Azure service that'll help make this happen and imagine how they fit into that manufacturing company's architecture.
Great. Let's start at the heart of it all. We've mentioned large language models powered by Azure OpenAI. Can you remind us what Azure OpenAI does and how it fits in?
Sure. Azure OpenAI provides access to advanced language models, think GPT-4 and similar models, hosted securely in Azure's cloud. Instead of training these massive models from scratch, which would be hugely expensive and complex, the company can leverage Microsoft's infrastructure. Azure OpenAI models can interpret user queries and generate human-like, context-aware answers. So when an employee asks, how many units of the new deluxe refrigerator are in stock? The model understands the intent behind that question.
So it's the brain that understands the language. Now, understanding language is one thing, but how do we get the data out of our documents, PDFs, and even internal databases?
That's where Azure Cognitive Search comes in. Cognitive Search indexes all the company's documents, those PDFs containing product manuals, warranty policies, internal training guides. It also supports vector-based search, which means it doesn't just look for keywords, it tries to understand what the user is looking for conceptually. For example, if you say warranty policy for commercial buyers, it can find the relevant text even if the exact phrase commercial buyer warranty policy doesn't appear. The AI model can then use this data to ground its responses. Instead of making stuff up or relying on generic info, the AI pulls answers directly from the company's actual documents.
That gives the AI real knowledge of the company's world, right?
Exactly. The model becomes far more trustworthy when it uses your own data. The documents become the source of truth. It's like giving the AI a well-organized library of everything your business cares about.
Now, what if an employee asks a question that requires looking up real-time data, like the current inventory level or the latest sales numbers?
That's where Azure Functions come into play. Functions are essentially small pieces of code that run on demand. Think of them as tools the AI can call to perform specific tasks. For the manufacturing company, one function might query the inventory database and return the current stock levels. Another could call a sales system API and get the latest order counts. The AI agent can say, oh, I need inventory data. Let's call the inventory function. After calling the function, it gets back structured data like deluxe refrigerator model X, 2,340 units in stock. Then it can present that info to the user in a friendly, human-readable way.
Got it. So functions basically let the AI do more than just talk. They let it act behind the scenes.
Right? Without functions or similar tool endpoints, the AI would just be passive. With them, it can initiate actions, fetch data, even trigger workflows. It's like giving the AI a set of utility belts. Instead of you rummaging through a dozen systems, the AI does the heavy lifting.
That's powerful. Now, you mentioned memory last time. Memory makes the conversation more natural. How do we store that memory?
This is where a vector store or a database like Azure Cosmos DB comes into play. Cosmos DB is a globally distributed database that can store JSON documents, user conversations, embeddings, and context. The AI agent can record what you've asked before, what data you're interested in, and any previous follow-ups. So next time you say, "Show me those numbers again," it knows exactly which numbers you're referring to, without starting from scratch. This continuity makes the conversation feel less robotic and more like talking to a knowledgeable colleague who remembers what you discussed last week.
So Cosmos DB is kind of the AI's long-term memory bank?
Precisely. Plus, Cosmos DB scales easily. If your manufacturing company goes global and thousands of employees are asking questions at once, Cosmos can handle that. It's built for high availability and low latency across regions.
Now, we've been saying employees just type a question into a chat. How do they get this chat interface? Is that a custom web app someone has to build?
It can be. But if you want a quick solution, that's where the Power Platform steps in. Power Apps lets you build graphical user interfaces with minimal coding. Power Automate can set up workflows that the AI agent can trigger. And Power Virtual Agents allows you to create conversational experiences without a ton of programming overhead. So your HR manager, who's not a developer, could whip up a Power App that includes a chat window connected to the AI agent. Maybe another app is for the supply chain team, tailored to their needs.
So the Power Platform lets non-technical staff build their own front ends and automations.
Exactly. They're low-code tools, so you don't need to be a hardcore software engineer to design something functional. This democratizes access to AI. Instead of waiting on the IT department, anyone with some basic training can build a user-friendly interface that talks to the agent.
Next up, security, reliability, and performance. We're dealing with potentially sensitive data, like internal sales figures or supply chain details. How do we keep it safe?
Azure Key Vault is one key piece of that puzzle. Key Vault securely stores secrets, API keys, and certificates, so no sensitive credentials are stored in code or plain text. This ensures that when the AI agent calls those back-end systems, it does so securely. For scaling and reliability, Azure Kubernetes Service, AKS, or Azure Container Apps can run the back-end services in containers. If your AI solution suddenly needs more computing power because many employees are online, these services can scale automatically. Add Azure Load Balancers or Azure Front Door to evenly distribute traffic and ensure everything stays responsive.
Monitoring and troubleshooting must also be crucial. How do we know if something goes wrong or if a query takes too long?
Azure Monitor and Application Insights give you observability. They let you track performance, errors, latency, and user behavior. If someone's request takes too long, you can see which part of the chain is slowing things down. Maybe the inventory database is lagging, or maybe a function call fails. With Application Insights, you get dashboards, logs, and alerts, so you can quickly fix issues and maintain a smooth user experience.
Let's put it all together in our manufacturing scenario. Say an employee from the sales team logs into a chat interface built using Power Apps. They say, "Show me the top 3 selling refrigerators in the Midwest last quarter. Walk me through what happens behind the scenes."
Sure. Step by step. 1. User query. The user's question hits the AI agent endpoint. The agent is built on Azure OpenAI and Power Virtual Agents, so it's ready to interpret the request. 2. Language understanding, Azure OpenAI. The agent uses Azure OpenAI to interpret the request. The model understands the user wants top-selling refrigerators, a region, Midwest, and a time frame last quarter. 3. Data retrieval, cognitive search and functions. The agent realizes it needs actual data. It might first check Azure Cognitive Search to see if there's any reference doc or summary on sales. If it finds historical summaries, great. More likely, it needs up-to-date numbers. So it calls an Azure function that queries the sales database. This database might be on Azure SQL or another source. The function returns a JSON payload, maybe items, name Model X sales 1500, name Model Y sales name Model Z sales 1150. 4. Context and memory. If the user had previously asked for something related to these models, the agent could recall that context from Cosmos DB. Maybe it knows the user often prefers data in a chart format or wants year-over-year comparisons. That memory is retrieved from Cosmos DB. 5. Response generation. Azure OpenAI again. The AI uses the data and context, then crafts a human-friendly answer. The top 3 selling refrigerators in the Midwest last quarter were Model X with 1,500 units, Model Y with 1,300, and Model Z with 150. Would you like a year-over-year comparison or details by store location? 6. Presentation to user, Power Apps. This neatly formatted answer is handed back to the user's interface. The Power Apps chat window displays the message. The user might say, "Show me a breakdown by store." The agent repeats the process, calls another function, pulls more data, and so forth. Throughout all this, Azure Key Vault is keeping credentials safe. Azure Monitor and Application Insights track performance, and AKS or container apps ensure everything can scale.
That's a beautiful orchestration. It really feels like we've got a team of digital assistants under one AI umbrella. Some are data fetchers, some are document experts, some handle security and scaling, and the front-end tools let anyone in the organization access this power.
Exactly. Each Azure service plays a role. Azure OpenAI for language smarts, cognitive search for document intelligence, functions for on-demand logic, Cosmos DB for memory, the Power Platform for easy interfaces, Key Vault for security, and Kubernetes or container apps for scaling, plus monitoring tools to keep it all humming. It's a well-oiled machine as long as you carefully stitch the components together.
That leads to the final question. How do businesses ensure they're stitching these services together effectively?
Start by identifying a clear use case, like our sales query example. Then build a proof of concept with a few services, maybe initially just Azure OpenAI, cognitive search, and a single Azure function. Test it, see how the responses look, refine your prompts and queries. Then add memory with Cosmos DB so the agent remembers context. Introduce the Power Platform so non-technical staff can get involved. Add security and scaling components as you prepare for production. Over time, integrate more tools, maybe speech-to-text for voice queries or additional agent frameworks for specialized tasks. It's a process of iterative refinement. You don't have to spin up every service on day one. The modular nature of Azure means you can plug and play as you go along.
Perfect. I think we've given listeners a solid roadmap of the Azure landscape for building these AI-driven systems. We started with just the idea last time, and now we've gotten into the nitty-gritty of each component and how they work together. This all makes the concept feel very real, very doable.
That's the idea. Hopefully listeners come away feeling not just amazed, but also informed and ready to try something out. The future's not just a dream. It's a set of services and capabilities you can deploy today, step by step.
Well, this has been enlightening. I think we've managed to translate a complex Azure architecture into an understandable conversation. To all our listeners, now you know how each puzzle piece fits, and you've got a clearer vision of how to bring your legacy apps into an AI-driven future.
Couldn't have said it better myself. Thanks for having me again. I'm excited to see how folks start experimenting and building.
Absolutely. This concludes part 2 of our deep dive. Stay tuned for more as we explore even more aspects of AI integration, best practices, and industry insights. Until next time, this has been Deep Dive, signing off.